Okay, this is the picture for number 5 and for number 6. And the idea is we're trying to find two different things. We're trying to figure out what this angle down here is. So we're imagining that the water is perfectly flat, and you're trying to find the angle from here down to there, assuming that this makes a gentle slope perfectly down like that. And the second part is we're trying to find this distance d over here. So to find this angle, the first part we have is we know that the distance from the edge of the shore out to the edge of the boat is 14 meters, and we know at that particular place it is 2.25 meters deep. So the easiest way to find theta is, again, good old SOHCAHTOA. In this particular case, we're going to use TOA because we have the opposite side and we have the adjacent side. We don't know what the hypotenuse is. That would be the slope of the water down like that. We don't know what that is. Now, interestingly enough, when we use tangent, it's the tangent of that angle is equal to the opposite side over the adjacent side. So the opposite side would be that 2.25 meters, and the adjacent side is the 14 meters by meters. So to find your actual angle, we talked about this before, you're actually going to be taking the inverse tangent, because to get that tangent over the other side, you have to do the inverse tangent of both sides. That'll cancel those out, and you'll just be left with theta. So you're actually going to be taking the inverse tangent of this 2.25 over 14. And make sure your calculator's in degrees, and you're good to go. Now to find the d, there's a couple of different ways to do it. Now that we actually know what the angle is from number 5, we could just deal with this big triangle. We know from here all the way out to here is 22 meters. This would be a nice little right angle. This would be the opposite side, so that would be d, and you would know this angle up here, so you could actually put in theta, and you really just do the same thing. You would just change your adjacent side, so you would have the tangent of theta would equal your opposite side, d, the thing you don't know, over this 22 meters. And then you have this angle, you calculate it in number 5, and then you plug it in and you find d, and you're good to go. That's probably the easiest way to do it. I hope this helped with number 5 and 6.